Hello everyone, my name is Elizabeth and we're going to look at the sine rule and how we apply the sine rule in science. And grade 11s or matrics, this one is how we're going to look at it. Remember we did previously in the previous lesson, when three forces are acting onto the same point and those three forces are in equilibrium. Remember then we know that there's no resultant force. Your resultant force equals 0 Newton because there's no winning force, there's no net force. Alright, so the sine rule works like this, and that is very important only when you have a triangle where there's no right angle. Alright, so it's a non-right triangle. So let's first look at how you're going to apply that. So I'm just going to give you a triangle and I'm going to say this is side A, side B and side C of your triangle. Then the angle across, straight across from side A will be angle A, across from B, the only angle across from B is that one. And the only angle across from side C is that angle, okay? All right, now in maths, you're going to learn also, and also probably how to prove this, but we're just going to apply it in our science classes. So then we could say, and our science classes, remember when we worked with, they're always going to ask you the third force, or what is the force in the rope, or the tension in the rope or in the cable. So we're always going to be wanting one of the sides. And I can in my vector diagram already figure out all my angles. So remember this is a non-right angle triangle. Okay, so then how it applies is we could then say that side A divided by sine of that angle equals then any one of the other ones, B divided by sine of that angle B. Of course it could also be C divided by sine of that angle we see there. So you see that what we're going to do is we're only going to work with two of them. We don't need all three of them. So how are we going to apply this? Let's say I'm asking you to work out for me the force represented by this side as A. Okay, but you do have that angle, you do have force B. In our case, we're not going to say B, we're going to say the force in the cable or whatever, that force. We do have that angle, so I'm just going to use this and rewrite it in a scientific way, where we're going to say not mathematical, A over sine A. I'm going to say, let's say the force or the tension in the cable divided by sine of that angle equals, let's say, the weight divided by sine of that angle. Okay, maybe that doesn't make sense now. But let's see when I do an example of such a question, how we're going to use the sine rule to do this. Okay, so very easy. Not going to get confused. I'm going to just do that easy and slow, and you'll quickly pick up on how it works. Okay, so what we've got here is they've got I'm going to put the question here next to my whiteboard. But anyway, so we've got during a mountain climbing exercise, this lady, mass 50 kilograms, is suspended. So we've got here a wall. She is suspended here. She's hanging here. That is her. There's her hands on the rope. Okay, and she's got a rope around her waist. So that is her waist there. There's the rope around her waist, and her legs is actually pushing against the side of that mountain or whatever. Okay, so what they do give me that angle as 20 degrees, and they do give me the angle that her legs make as a 45-degree angle. So this is her legs, so it's the force, we could say, of her legs. We could also say it's an applied force, so she's pushing herself away from that, and just say F applied. I can also say F applied force. That will then be the tension in the cable working up there. And then where's the third one? I've only got two now. Where's the third one? The third one is what? Of course, her weight. And weight, or Fg, gravitational force, is always down towards the center of Earth. Okay, so I've got my three forces. So yes, in which direction is this legs of her pushing? The legs of her is pushing her away in that direction. And the tension in the cable is towards the mountain there, that's where it's attached. Because just remember, if it's not attached there, she's going to fall. So the tension walks towards, it's like somebody's holding her there. In which direction is that force working? Upwards. And which direction is the legs working? In the opposite direction. Otherwise, if it would have worked in this direction, it would have pulled her even closer to the mountain. No, it's not pulling her closer, it's pushing her away from the mountain so that she's not hanging straight down the mountain side. Okay, so that is the direction of my three forces. Okay, now draw a force diagram. Okay, so I'm going to just redraw it. That is my point, and that is there. The rope is around the waist there. So we've got our tension in the cable going up. We do have to give at least one angle in a free body diagram with my dotted line there. That one I'm just going to move to this side to show it's working upwards, and we can say that's the applied force done exercised by our legs, and that is the gravitational force Fg or W straight down. So there's my free body force diagram. Again, what is the marks? 3 marks. Do I have 3 there? Yes. T and the arrow. Fg and my arrow. Fa and my arrow. Go. Next question. Determine the magnitude of the force which the rope exerts on her. Okay. So what do we know to do? Guys, what is the first thing I do when I know there's 3 forces acting on the same point and they are in equilibrium? I know I can do a vector diagram where I'm going to move them to form a triangle. Okay, so please, 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 some kids always use this triangle and say, okay, well, that looks like a triangle to me. I heard something like I have to do a triangle, so that's the one. No, 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 no. What do? From our force diagram, the only thing I'm now going to do is I'm going to move them. So there's my Fg going down, gravitational force. I have to bring this and add it on here. So it's going to go up to there and it will be my Fa. But now I have to figure out what is the angle here. Now what do I see? They do give me this angle with a vertical line. And I do have from that vertical line that the force there is going to go upwards at 45 degrees. So perfect, I've got that one as 45 degrees. So that is the direction in which that Fa is working, my applied force. Alright, then I know I've got to finish, add that one on head to tail, and I'm going to finish up here as a closed body diagram. So that is my tension in the cable. So that's that one, and I've just moved it to here. What is the angle where the arrow comes onto the vertical line? The arrow of T comes onto the vertical line at an angle of 20 degrees. So you're going to say to me, Mom, it does look like that one. Yes, it is in this case very similar. But guys, no. Use your free body diagram and from there move and create your vector diagram. Alright, now this is for 8 marks. Now why 8 marks? Because I don't enough. I have to work out something else. I've got that angle and that angle. Okay, so that gives me a 65-degree angle, but we know the angles of a triangle is 180 degrees. Minus my 65. So at least I've got this angle as 115. Perfect. So I don't have what we call a right triangle. It's a non-right triangle. So I'm going to have to use the sine rule. But still, I don't have the value of that force or that one or that one. But maybe I can work out this one. Why? Let's go back to what did they give me. They gave me that her mass is 50 kilograms. And the moment I've got the mass here, I can work out. Alright, so Fg, the gravitational force on this girl, would equals mg. Her mass is given as 50. Let me just make sure, already forgot. Okay. Times 9,8. Let's work that out. So 50 times 9,8 gives me 490 Newton. So now you see I've got this one. Okay. So I've got that side and that angle. And I asked the tension in the cable, but I also have that angle. So what is the sinus rule again? The sinus rule again is that A, side A, over sine of the angle A equals side B divided by sine of the angle across B. But for this formula, I'm not going to get any marks. So listen guys, first translate it into physics language. Now physics language, A is representing what? Now here I'm also always going to use the one that I'm trying to work out, the one that I don't know, so unknown. So my unknown that they ask me to work out is the tension in the cable. So I'm going to translate that to tension in the cable T. Divided by sine of that angle, theta, of A. So I'm going to just write the theta. Divided by side B. Now I'm going to use the side that I have. Now in this case, I've worked out my Fg. So I've got this side. So that is going to be my Fg. Divided by sine, let's say theta 2 of that angle. And now I've got something that looks like physics and not just maths. Okay? So I'm going to work out T divided by sine, and what is the angle across from T? 45 degrees equals Fg. I've worked it out, there it is. So I'm just going to substitute 490 divided by, now what is the angle across from Fg? That is sine 115 degrees. So let's work that one out. So we've got 490 divided by sine 115 gives me 540.65. 55. Now what do I do with this when it's divided on this side? I'm going to take it over and I'm going to multitude times 45 degrees equals. So I've got my already that on my calculators times sine of 45 degrees. And the tension in the cable is going to be 382.30 Newton. And there is my answer. I'm not so sure that you can still see that. So let me rework it out again. So I'm just going to move this quickly to here. So we've got the formula there. T over sine theta equals Fg over sine theta. And then I'm going to substitute. So T equals Fg 490 divided by sine 115 degrees. I'm going to get rid of this one on this side by saying times sine, and what is the sine over? my T, across from T, it's 45 degrees. Okay, and I'm going to work that out. So 490 divided by sine 115 times sine 45, and I got to my answer as 382.30 Newton. So why the 8 marks? Firstly, I had to draw a vector diagram. So they could give you marks for that, not necessarily. They're definitely going to give me marks for working out my weight, so that I've got one of the sides of my non-90 degrees triangle. And then they're going to give me marks for the formula that I've used here, and then my substitution and my answer. So there is a beautiful example of using the sine law of maths. So we're going to only use it again when we have a triangle, we've got all the angles and we've got at least one side, or we can work that one side out. And then we're going to use that to determine the other forces that they ask me. All right, so I hope that makes sense, guys. Okay? Believe in yourself, you can do this.